Good morning, everybody. This is Lou Huger calling in from the University of Idaho Extension here in Boise. We're going to go ahead and get started because we're sitting right at 11 o'clock. And again, as promised, we have about an hour of content. So today we have Ariel Agenbroad with us today. She's an area extension educator with the University of Idaho Extension. Most of us have seen her, know her face because she is with us all the time. But she's going to actually be teaching today's webinar, not me. So we're going to be talking today about the approaches to composting safely under the produce safety rule. So basically making, purchasing, and using compost in accordance with the produce safety rule, which is something that, based on survey feedback that we get from a lot of different curriculum and programs that we have, it's something that we still get a lot of questions about, which is understandable because it's a tricky topic and something that growers encounter all the time in their operation on a day-to-day basis. So we're going to go ahead and get started with this topic. Thanks for joining us this morning. So just a little bit of webinar housekeeping. We've seen this in the last two webinars that we've had, but just a quick reminder for those of us that haven't been here, maybe are tuning in for the first time in this three-part webinar series. First of all, make sure that you go ahead and close all other programs you may have running on your computer just to preserve your bandwidth. That'll really help you with the speed of our presentation today. Secondly, if you start having any types of issues with your sound or clarity or your picture, go ahead and call in on the number that we provided. You should have gotten an email yesterday and then also today it's from Zoom technically, but it says from Lou Huger, and that's how you probably got into the meeting today. But at the bottom, there'll be a call-in number. You'll be able to call in even if you aren't able to see what we're talking about. At least you can hear and still get some of the content. And then I will also send out a recording just like I do each time, so you'll have a copy of it if you would like to watch it back. Third, we will have the chat on the bottom of the screen right in the middle where you can pop in any questions you have as we're working through the material today. We will have a Q&A here at the end with Casey Mon from ISDA, Ariel, and myself, and we'll address any questions we get in the chat and also that we get at the Q&A towards the end. And then we will be sending out a bunch of great resources as well as a hard copy PDF of the slide deck. Ariel's going to be discussing a bunch of awesome resources related to composting under the produce safety rules, so I'll make sure everyone has a copy of that. They'll also be linked onto our website as well as all of the other past 5 webinars that we've done in the last 2 years, the recordings of those and all the resources, which I'll discuss towards the end of the webinar. And then lastly, I just want to make note that we will be not talking about anything related to COVID-19 today, related to produce safety. If you need help with that, we do have some good resources and I can hopefully connect you to the right person, but we won't be discussing that today. We'll only be talking about the produce safety rule. So thank you so much for being here. We're going to go ahead and get started, and I'm going to kick it off to Ariel to get started with her presentation.
All right, thank you so much, Lou, and thank you to everyone who's joining us today to talk about compost and biological soil amendments of animal origin. So I'm going to start off by talking a little bit about our objectives for the day, and our hope is that after this webinar, you may or should have a better understanding of how biological soil amendments of animal origin, or BSAAOs for short, and their use are defined in the produce safety rule, or PSA for short. So if you see those two acronyms throughout today's talk, that's what they mean. We basically mean pooped-based soil amendments, and we mean the produce safety rule when we say PSR. We're going to talk about how to determine whether one of these BSAAOs is considered treated or untreated according to the definitions codified in the produce safety rule. We're going to talk about thermophilic composting and the practices that comply with the rule. We'll talk about documents related to the procurement, processing, and application of these materials on your farm, and hopefully guide you to some additional resources to assist you. So as Lou mentioned, this presentation is really designed to meet the questions that we continually get either in our Produce Safety Alliance grower trainings or through on-farm readiness reviews, or even during inspections. So that's where some of this need came from. So hopefully we answer your questions today. And if you have additional questions, send them our way and we'll get you an answer. So we've started off every one of these webinars with just a really quick review of the Food Safety Modernization Act. For those of you that may be new to this, most of you have been through one of our trainings or you've been hearing about this for some time, because the Food Safety Modernization Act, or FSMA, FSMA was signed into law in 2011. So it's taken us this long to get to where we are. Obviously, it's a pretty complex rule with a lot of components. And what it did is it gave FDA, or the Food and Drug Administration, the authority to regulate food from farm to fork for the first time ever. And it was also the first sweeping food safety regulation overhaul since about 1938. So the produce safety rule in particular is just one of the rules under the FSMA Act, but it establishes these science-based minimum standards for safe growing, harvesting, packing, and holding of fresh fruits and vegetables that humans typically consume raw. Just a quick reminder, all farms, foreign and domestic, must comply with the produce safety rule and other aspects of FSMA where applicable. In Idaho, our Idaho State Department of Agriculture holds the regulatory authority and conducts inspections of covered farms. And they also verify the exemptions, because not all farms are subject to the produce safety rule. And we can help you with that. Casey, who's on the phone right now or on the webinar from Idaho State Department of Agriculture, he can help you with that too. And then we've also created this online decision tool. It's a self-guided, anonymous app that lets you just go through and determine, based on a number of questions, where you might fall out, whether you're covered, not covered, or you might be eligible for a qualified exemption. So knowing where you stand is really going to determine how much of today's material you need to fully incorporate onto your farm, or whether these are just some things that you should really consider working toward because they are some best practices. So will your farm be covered, right? If you know that you are a covered farm, you're growing produce and you're growing it in the quantities and sales amounts that put you smack in that level, then yes, today's stuff is going to definitely apply to you. But if you're a smaller farm, maybe you qualify for the qualified exemption, you sell mostly at farmers market, you're not going to be required to follow these regulations, but it's a good idea to pay attention and to think about it. And especially as we talk about composting, these are universal principles for the best kind of composting. So they really apply to anybody, no matter what size farm you are. So if you're following along with your FSMA rule, which I'm sure all of you have it out in front of you and you're reading along with us, this section entirely deals with subpart F, and in particular sections 11250 through 60. And this is the section, or the subpart, dealing with biological soil amendments of animal origin and human waste. And this is just the really brief little FDA definition of this subpart. But where we're focused today on this is this part that's determining the status of a biological soil amendment of animal origin, right? We're going to talk about the acceptable treatment processes, what we mean by microbial standards, application requirements and intervals currently, and record keeping requirements. So this is where we're focused today. The handling, conveying, and storage, we talk about that a lot in our Produce Safety Alliance grower trainings. It's not the focus of today. We're really looking at these factors that I've highlighted here. So let's get in. Not literally, right? Why are we concerned about this? Why is this something that we're talking about? Well, this table here, I think, really illustrates why we're concerned about biological soil amendments, particularly those of animal origin. So if you look at this table, this is a risk table, right? Of least risk for human pathogens or things that'll make you sick, and the highest risk. So you can see the highest risk products that you might potentially use would be human waste that's untreated or raw, that's coming in contact with the harvestable portion of a fresh produce item close to harvest, right? That would be worst case scenario. You do not want to eat that food. Coming down the list, we have animal-based manure waste products. And again, untreated or raw, close to harvest, contact with that harvestable portion, this is when it's most risky. However, if we compost it and we make an effort to minimize contact, and we apply it further away from compost or from harvest, we're moving down that scale closer to the least risk. And then the least risk would be non-biological soil amendments that have been pasteurized, heat treated, or in other way chemically reacted to reduce or remove pathogens. We apply it way, way, way far away from harvest, and we make no contact with the harvestable portion. Now, that's not necessarily realistic in a farming scenario, so we're really trying to balance this out, right? We want to reduce our risk, but know that we're never going to fully eliminate all risk whatsoever. So the rule defines treated versus untreated. And this is something we've talked about in our trainings too. And it's always worth revisiting just so that you really understand the difference, because this may not be language that you're used to using. You might call it raw manure versus finished compost, right? But in the produce safety rule, we're using the terms treated and untreated. So a biological soil amendment of animal origin is considered treated if it has been processed in some way to completion that reduces the microorganisms of public health significance. And we'll refresh on what those organisms are in just a minute. Now, we consider the material to be untreated if it has not been processed in that way, or it's become contaminated, or has been combined with an untreated product. So maybe you had finished compost and then it got contaminated with raw manure, right? And if that material is or contains some other component of untreated waste that may be contaminated or has been associated with foodborne illness, then it's considered untreated. Now, why should you care as a grower? Well, this is the key point, and I think this is the part where growers have to decide what it's worth to them, right? If you want to have the freedom to use compost on covered produce crops, so say you're growing, fresh tomatoes, and you want to top dress those plants at any time during the growing season up until harvest, then you have to use a soil amendment that is considered treated, right? So if you want to come through here and use compost as a mulch or apply it when your crops are looking a little bit hungry, then you need to apply a treated product. Right? And that's because an untreated product may not be used on covered produce at any time during the growing season. We'll talk about when you can use it and how, but just this is the key difference between these two in terms of why, as a grower, you might care or why you would want to use one versus the other. So what is treatment, right? We mentioned that it was some kind of process, right? And so according to the rule, it is a scientifically valid controlled process that can either be physical, like heating, chemical, like using high alkaline pH, or biological, like composting, or some combination of the above that has been scientifically tested and validated over multiple experiments in time to satisfy the microbial standards set by the rule. And we're particularly looking at the microbial standard for 3 primary pathogens: Listeria monocytogenes, Salmonella, and E. coli 0157H7. These are the microorganisms that make us the most sick, that can lead to death. And they're also the microorganisms that are most commonly present in waste products. And so this is what we're concerned about. We're concerned about these biologics being active in the waste products, coming in contact with the food that we eat. It's really that simple. So we're going to get into a little bit more about the treatments, but I wanted to just jump over to some of the common questions that we get when we're talking about these products, because there's a little bit of gray area. And even in the rule, I think sometimes it's really hard to get a definitive answer. So a question we get a lot, especially from organic growers, is what about agricultural teas, right? Or you're using compost tea. And typically this is like a brewed, aerated, either foliar or soil applied amendment made from compost. And often there's a lot of other biologicals or food added to increase the biological activity. So you may be able to consider an agricultural tea treated, right? So for use at any time up to harvest, if you use treated compost to brew the tea. And if you use potable water to make the tea, so this is water that has no detectable E. coli. So we definitely wouldn't be using irrigation water or pond water or any other untreated surface water to make the tea. And then here's the kicker too, and I think this is what would probably have the most impact on some organic growers, is that you cannot add any microbials or tea additives, even things like molasses, sugar, yeast, algae powder, things that are going to feed the microorganisms. Once we add that, then this becomes an untreated product and we cannot use it on the harvestable portion during the growing season. So I hope that that kind of answers that. This is something we're still trying to get really solid answers on. I know that I had a conversation with the program manager for the state organics program, and this was a question that she had. And so this is really my best answer right now, right, is that it can be considered treated if you use treated compost and potable water, and as long as you don't add any other microbial or additive to the tea. All right, so I don't know what was in that tea, but whatever it is probably not going to qualify. Okay. So another question that we get too is what about worm composting, right? Because worm composting is a really great, efficient way to break down waste, you know, and some are even doing it on a pretty large scale. I know some farms in Idaho are. I know even some, you know, some restaurants, schools, food service might be interested in using this to break down waste. And yes, it does a really great job of composting and digesting organic matter into a compost. However, because vermicompost is generally not heat treated, right? It's based on the digestion by these worms. It's best to use worm castings as an untreated amendment, unless it's somehow been heat treated or chemically treated, which I think most people would not want to use it in that case. So again, this is something that probably needs a little bit more exploration, but for right now, I would consider vermicompost untreated, and I would use it in the methods that we're going to outline for using untreated amendments, right? I want to just really point out that the rule does not prohibit you from using untreated composts. It just tells you that there are some limitations in terms of when and how you use that. So let's get into that part. Your options when you're using biological soil amendments of animal origin of any kind are these. You can use it untreated. You can treat it on your farm, right? So you can conduct scientifically validated processing on your farm, or you can purchase treated products. So these are your three options, or really you have four options because you can choose to not use any biological soil amendments of animal origin at all. And some farms do, you know, some commercial farms are not using you know, organic materials or manures, but a lot are. And so this is how we do it safely. So if you are using untreated, right, you don't have access to treatment, you're not going to be composting on farm, your options are here. Do not use it at all, right? I said you could do that. Use it on non-food crops. Use it all you want on non-food crops, as long as you're following some basic environmental rules about not just spreading manure wherever you want. You can use it on food crops with appropriate application intervals that we'll get into. And you'll want to keep application records, and I'll get to why that is a little bit later. Okay, so those are your options for using untreated soil amendments. Now, what if you want to treat it on the farm? Well, then you're going to compost your manures on farm using a scientifically validated method. And this will enable you to apply your crop to your crops at any time. But you are going to need to keep process records that document that you were using that scientifically validated method to make your compost. And if you're going to purchase commercially treated compost and you want to use it again at any time in the growing season, then you'll purchase compost manure products from a supplier who's using a scientifically validated method. And you'll need to obtain documentation from that supplier that they are processing it in that way, right? And we're going to break this down a lot further. So if you've attended any of our Produce Safety Alliance grower trainings, this is really the takeaway from our section on biological soil amendments, but we're going to go a lot deeper today into these processes, into the documentation, etc. All right. So I just wanted to point out too, using untreated manures, and I love this picture because we've got some turkeys grazing in this field, right? They are applying untreated manures to this field. So just be aware of all the animals on your farm too, and if they're inadvertently manuring as they travel around, right? So if your farm is subject to the rule, right, you're covered by the rule and you're using untreated manures, or you've got compost that lacks the documentation, we highly recommend that you keep records of when and how these materials are applied. Because the thing is that the inspector, if they see them on your farm, right, and they understand, okay, you use manures on your farm, you have livestock on your farm, how are you using those materials? Right? Record keeping for this is not a requirement of the rule, but if the inspector is asking you those questions and they see the manure there, if you have application records or some records dealing with these products on your farm, it can make it a lot easier to verify that you are indeed complying with the produce safety rule and not applying these untreated soil amendments when you're not supposed to be applying them, right? So that's just a I know it kind of doesn't make a whole lot of sense, but it would really help you to protect yourself and reduce additional questions, right? It just says, nope, we only apply it at this time, and here's our record of when we applied it. So once we're talking about this, right, we're talking about what are, when would we apply it if we have untreated soil amendments of animal origin. So I'm going to mention that the FDA, Food and Drug Administration, in collaboration with the United States Department of Agriculture, is currently conducting their own research and assessments to evaluate the risk of human illness associated with consuming produce that has been grown in areas that are amended with untreated biological soil amendments, right? So they're applying manures to cropping areas, and they are doing research on that. And they also want to understand the impact that different agricultural and ecological conditions may have, and as well as researching their own time intervals or intervals between application and crop harvest, right? And looking at what the risk might be along that continuum of interval. But that could be, that was predicted to be 5 to 10 years out after implementation of the rule. So we do not have this information yet. So in the meantime, FDA has established that if growers are following the National Organic Plan requirements through the USDA National Organic Plan, they may continue to do so until further guidance is provided. So if you're an organic certified farm, or if you've looked into that, they do have a very specific interval application recommendation for using manures, particularly because organic growers are so focused on the biological soil health and you know, the utilization of on-farm resources. So manure has been a part of organic agriculture from the very beginning. So what is that regulation for the manure and manure-based compost in the organic rule that you can follow now to be in compliance with FSMA? Well, in this section of the National Organic Plan, it says that raw animal manure must be composted unless it is applied to land used for a crop not intended for human consumption, or if it is, it's incorporated into the soil not less than 120 days prior to the harvest of a product whose edible portion has direct contact with the soil surface or particles, or incorporated into the soil not less than 90 days prior to the harvest of a product whose edible portion does not have direct contact with the soil surface or soil particles. Now, a little bit more visual format, right? So if you're going to be using untreated compost or manure of any kind, and you're going to be using it on something that grows in the ground or on top of the soil surface, right? You must wait 120 days between that application of the manure or the untreated compost and your harvest for the produce that contacts the soil. And if you're growing any above ground produce, or like this jalapeno here, you wait 90 days between the application of raw manure or an untreated compost and harvest for produce that does not contact the soil, right? So 90, 120, depending on if it grows in contact with the soil or not. And this is something we presented in our trainings as well, but I'm just getting into it in more depth here. And we'll revisit this one last time before we're done today. Now I want to get into composting. So, and then maybe that is why many of you joined us here today. What's the dirt on composting? What are the options for doing it yourself on farm? And according to the produce safety rule, farms can use any treatment process or processes that have been validated to meet the relevant microbial standard in section 111255 without the need to test the end product. So this is really nice, right? You don't have to test your compost, have it lab tested or approved if you follow a process that's been validated already to meet the relevant microbial standard. So what is that microbial standard? All right, well, here is the microbial standard for biological soil amendments of animal origin. This is right what we don't want to find in the finished product. So for Listeria, the microbial standard is not detectable. We want to use a method that can detect 1 colony per 5 grams of milliliter, or 5 grams or milliliter if you're sampling liquid, right? It has to not detect salmonella using a method that can detect 3 probable numbers per 4 grams or milliliter if the liquid. And also for E. coli, that it's not detectable using a method that can detect 0.3 MPNs per 1 gram or milliliter. So we're really looking for some method that is able to measure these 3 microorganisms and not find them, okay? So we don't want these to be in the finished product. So what are those currently validated processes, right? I said that you could use anything that was a currently validated process. Well, right now in the rule, you have two options. You have turned thermophilic composting or static thermophilic composting. And I'm going to break down thermophilic. That's a good one for a composting talk, right? I'm going to break it down. We're going to get into it. So two scientifically validated treatment processes right now have already been validated and shown to consistently meet the microbial standards codified in the produce safety rule if used correctly. So if your operation is following one of these two examples, the turned or static composting, then you would not have to do any process validation of your own. You wouldn't have to have a scientist work with you to make sure that your process is breaking down materials and generating a product that tests negative for all those microbials, right? So these are the two that you can use. And I want to give a big shout out to my colleagues, Dr. Lead Chen and Mario Dejaro Marti. They are both our nutrient management engineer and educator. They work out of the Magic Valley, where we have a lot of poop, right? A lot of dairy manures. And they work specifically on helping growers and farm managers become better at the composting process. So a lot of the material that I'm going to share to you today on these two methods is coming directly from these gentlemen and the research that they've conducted, as well as other research coming from FDA, USDA, and even EPA, because these systems have been continually validated by multiple organizations, agencies, and institutions. Right, and so these are two of the handouts that Lou has made available to you. The first one is the composting process, and the second one is on-farm composting management, and they are both co-authored by these gentlemen, Dr. Chen and Mario. So I really owe them a lot for teaching me about composting and being a great resource to anyone in the state who is pursuing this on a large scale. So let's start talking about composting. So thermophilic composting, right? The word therm in there gives you an indication that we're talking about heat. So how and why does it work to reduce pathogens? Well, first of all, if you start a compost pile that is the sufficient size, density, and composition of materials and moisture level, right away, mesophilic organisms, so microbes that are happiest in the range of about 75 degrees to 105 degrees Fahrenheit, are going to start the composting process. They're going to start becoming active, they're going to start digesting, and as they work and start to break down material, they're going to start to heat everything up. At that point, these thermophilic microorganisms are going to take over. These organisms thrive at temperatures above 105 degrees. They like it hot, right? They're going to be eating and consuming and excreting wildly as the temperatures increase. And so as this happens, the temperatures in your compost are going to increase to 130 degrees to 150 degrees, sometimes even within the first 24 to 72 hours of pile formation, if you put that pile together correctly. And they can the temperatures can remain there for a period of several days to even several weeks. And this is really the key element that we're looking for. This time, when the compost materials are heating up to that 130 degrees and higher, this is what we call the active phase of composting. And this is when decomposition of the materials that went into that compost is going to be most rapid. And in this stage, the thermophilic stage, these temperatures are high enough to kill the pathogens that we're concerned about, as well as weed seeds, and also it's hot enough to often really render useless a lot of other chemicals or toxins that would normally be harmful to plants. So this is where we want to be. This is the sweet spot for the thermophilic phase, where we've got those temperatures high enough to kill the things that we're worried about. Now, during this active phase, though, right, I said that these thermophilic microorganisms are just going crazy, right? They're eating, they're breeding, they're reproducing, they're excreting. They need a constant source of food to do this, and they need a constant source of oxygen. And so our goal as a composter, right, is to, number one, create a pile that has enough food in the right ratios to support those microorganisms for those several days to several weeks, usually several weeks, that's needed to fully break down the material. But they're also going to need oxygen. And we can do this through passive means or forced aeration, right? Or we can manually turn the compost pile. And so this gives us a clue as to why we have the two different methods that we use. So method one, the turned composting. And I think if you've ever been a home composter or you've composted on a very small scale on a farm, this is the type of composting that you're most familiar with, right? You make a pile and you water it and you flip it, and you water it and you flip it, and you turn it and you turn it. And as you do so, you're bringing the outside cooler materials into the center where they can heat up, and you're also recirculating oxygen and bringing that fresh air into the pile, which then continues to ignite those microorganisms and keep them going at those high temperatures. So turned composting involves forming organic waste into rows of long piles called windrows or large conical piles, and aerating them periodically, either by manually or mechanically turning the piles. So the gentleman in this photograph is watering the piles, and then he's going to turn them with a pitchfork. You can also turn them with a front loader, which is often how they're done on a medium size or small farm. And then in large compost operations, these are done with specialized mechanized equipment that turns the pile, usually with some kind of tractor pulled implement. So if you're using a turned compost method, right, this is the standard for the rule. It must maintain aerobic conditions and keep that temperature 131 degrees Fahrenheit or higher for 15 days. And this can be non-consecutive, but we need to have at least 15 days documented of that temperature with a minimum of 5 turnings followed by curing. And I'm going to get to curing after I talk about these two methods, right? So we've got to turn it at least 5 times. And we have to document that we're reaching temperatures of 131 degrees during that time frame, during those 15 days, right? And it doesn't have to be every day, but it needs to reach that for 15 days. So how do I know when to turn my compost, right? Well, and this is the thing, I'm not going to be able to give you one size fits all perfect recipe or set of directions in this presentation. It's just not possible. So much of what composting is really dependent on what you start out with, what you have to work with, your farm size, etc. So the same thing goes with turning your compost. So when do I turn it, right? How do I know when? Well, your pile turning schedule is going to vary pretty widely depending on how compact your pile is, your temperature levels in the pile, the consistency of the mix that went into your original, your original pile. How much labor and equipment do you have available, right? Do you have time to go out and turn your compost every week, or do you have to wait longer? The length of your growing season. In a lot of parts of Idaho, we have a pretty short growing season, and you might be trying to make your compost pretty quickly because it's just going to be a little bit harder to make a really efficient compost when it's very cold outside. And then again, how soon you need that compost, right? So you've got a few things that are going to determine how quickly you turn it. The number and frequency of how often you do this is often really best determined through your own experience, right? And using what tools you have available to you and figuring out, where is your sweet spot for keeping that temperature where it needs to be, and also having things break down in the time frame that you expect. So what about static composting, right? Those two methods. So the first method is the turned, the second is static. So in aerated static pile composting, you've got organic waste that are mixed into a large pile. Sounds familiar. In this case, though, we tend to add more bulking agents, things like wood chips, newspaper, straw, so that we have more airflow, right? They're a little bit lighter piles. And then these piles can be placed over perforated pipes. Here in this example, we have perforated PVC pipe. And these either deliver air into or draw air out of the pile passively, or to speed this up, growers will actually use pipes that have been capped at the ends and then perforated along the centers. And they use air blowers to actually blow air through the pile to increase that oxygen and to keep those microbes going. All right, so this is a pile that you would not turn. You would simply use forced or passive airflow to oxygenate the pile and to keep it going. And both methods are very effective when they're done right. And so according to the code in the rule, right, if you're going to be using static composting, you must maintain the aerobic conditions at a minimum of 131 degrees Fahrenheit again for 3 consecutive days, followed by adequate curing. Right, so that's not very long. But that temperature in 3 consecutive days is enough to reduce the pathogen load. And again, I'm going to talk about curing here in just a minute. I have watched Mario give a presentation on this method, and I've watched him build piles, and it is really incredible just how fast this really works if you put it together correctly. And that's why we've given you those publications so that you can really figure out what is your recipe. We're going to talk about that more here in just a second. So we're talking about a lot of hot air to make static aeration work really well in composting. So in these aerated static piles, these following things are really critical for establishing the sufficient and well-distributed airflow during the critical compost process. So the pipe size is going to determine how much air is going to be brought into the system. If you're using a blower, what capacity blower you have, and I've seen them use everything from a leaf blower that has been modified to specific blowers made for this purpose. How you construct that pile, right? The mix of materials and the balance of carbon to nitrogen, bulky to non-bulky materials. How well you initially mix the materials. So this is a little bit different too. Often when you're doing a turned pile, you might layer materials, you might throw things in when you have them. But in the static forced air composting, you really do all the mixing ahead of time so that you have this uniform blend of materials. And then you push the air through it and everything breaks down together. And the initial particle size, right? How big those individual material pieces are is also going to be important. And once an aerated pile has been built, right, that we leave it, we don't touch it. So once it's been built, you can only adjust your aeration by controlling your blowers based on temperature or on a time schedule. So you can't go back in. I mean, I guess you could, but it would be an awful lot of work and mess to have to go back in and readjust your pile. So build it correctly, figure out what your airflow is going to be, and then aerate it correctly. And like I said, I've got resources to help you to figure out what that's going to be for your farm and the materials that you have. So you might be thinking, well, which method do I want to use? So here's kind of the breakdown of these 2 methods and what you might want to think about if you're thinking about doing composting on farm. So if you're doing turn composting and you have a lot of material to compost, right, then you might actually need a lot of land to do the composting because you have to lay out these windrows or these piles. You also need to have some kind of sturdy equipment that you're going to use to turn it, unless you're going to do it all by hand. And if you're going to do it all by hand or even by machine, you need to have a continual supply of labor to maintain and operate the process. And you have to have the patience to experiment because various mixtures, materials, and turning frequencies are going to either make the compost happen faster or slower. And there's definitely trial and error with any composting. However, if you decide that you want to use static composting, right, you like the idea of set it and forget it and it composts really quickly, well, it also requires really carefully monitoring because you want to make sure that the outside of the pile heats up as much as the core. And again, to get started with forced air or static composting, there might be more costs up front and technical assistance to purchase and install the maintain equipment, such as your blowers, getting the right size pipes. If you're going to automate any of it, then you would have temperature and moisture sensors and potentially fans. So there's a lot more in the setup of static composting, even though the composting itself takes less time. And the turned composting, you can kind of start as a beginner and, make a pile and see what happens, but it is going to take more time over the long haul and more attention to make sure that things are happening the right way. So whichever method that you use, there's some general considerations for high quality compost. And I'm going to get into those now. So there are quite a few factors that contribute to being able to make really good compost. And so I'm going to talk about them here. And this is, again, why I can't just give you a simple recipe for how to make compost on your farm, right? A lot of this is going to depend on what you have. So the materials that go into your actual compost are going to be a big deal. And apart from that, oxygen, right? In order to break down composting and result in fast decomposition, we've got to be able to introduce oxygen into the pile. And so in a turned situation, we are actually manually introducing oxygen into the pile through turning. And if we're using the passive or forced air, we're allowing the air to do the work for us. Maybe we're blowing it, or maybe we've just created perforated pipes. So that aeration is distributing heat and moisture, it's incorporating oxygen, and it's distributing other gases that might be trapped within the composting material. So nutrients is really important, right? As the microorganisms are breaking down material, they're doing it because they're feeding on those materials. And they need both carbon and nitrogen for energy and protein synthesis and reproduction. So getting that carbon to nitrogen ratio at the beginning is critical to ensure that those thermophilic pathogen reduction temperatures are going to be achieved. And a general rule of thumb, right, is to incorporate your feedstock, and this is really just your raw materials, right? Feedstock is a composting jargon for raw materials. We're looking at potentially a 30-to-1 carbon to nitrogen ratio. And if you've been a home composter, you often think of these in terms of browns and greens, right? So browns would be your leaves, your straw, your wood chips. These are your heavy carbon materials. And then your nitrogen are your green grass clippings, your kitchen scraps, really juicy wet wastes. So about a 30-to-1 ratio is a good way to start. Moisture is also really key for supporting the metabolic processes of those microbes, right? They need water in order to do their job. And it also allows for chemical reactions, the transport of nutrients, and the microorganisms, like I said, to thrive. The porosity, structure, texture, and particle size of your feedstocks or your original materials are going to have a great deal to do with the aeration in the compost pile, and also how quickly those materials are able to be broken down. If you've ever piled all of your yard waste annually in a big pile and left it and visited next spring and noticed that it didn't change at all, then you understand how the structure, texture, and particle size might have an impact on your composting. pH. Aerobic microorganisms do grow really well around a neutral pH. We don't always have control over that based on what we're trying to compost, and especially a lot of our animal manures are typically going to be a little bit more alkaline than that. Again, temperatures, it's key that we reach temperatures above 131 degrees Fahrenheit to ensure that pathogen kill is being achieved. And that homogenization, either before you start or in a static pile, or that turning that happens in a turned pile, encourages that proper moisture distribution, that aeration, and exposure to thermophilic temperatures for every particle in that compost. And time, right? I talked about the time required to make sure that we're reaching those degree days for a long enough period of time to reduce the pathogens that we're concerned about. Okay, so what goes in your pile? Again, I mentioned that possibly a 30-to-1 mixture of carbon to nitrogen, if you have it. And so that makes you think too, if you're composting manures, you've got to have a lot of browns to go with that green, because that manure is going to be a green. Typically, if you've got animals that are in bedded conditions, then you often have a lot of that carbon in the bedding material. But so the properties of those materials are going to be really important. How you intend to use your compost, right, might have an impact on what goes into your pile. Your own observations and experience with those raw materials, or can be a determinant on how you make that pile, right? You're like, well, this has worked really well for me in the past. I know that my materials need to be about this size. I put this much brown, this much green. This is my ratio. This has worked really well for me, right? So your experience is going to help you. If you're new to this, or if you're starting with materials you have not used before, or maybe a method you haven't used before, you can actually calculate some precise compost recipes using formulas and computer spreadsheets that are based on the characteristics of the available raw materials you have that you want to compost. And in those two publications that I shared with you, you've got a chart in there of if you've got manure, or if you have wood chips, or if you have grapevine prunings, whatever material you're starting with, we can probably help you come up with a recipe for putting those together. And that's where folks like Marty and Dr. Chen really come in handy in helping to craft that for us. So size matters when we're talking about compost piles, right? A little pile is just not going to compost, and a pile that's way too big is probably not going to compost. So there's a happy medium, and at the very least, your compost pile should be about 1 cubic yard in order to heat up and stay hot. That's your minimum size. And then beyond that, the ideal height and width is going to be based on a few things like the ambient temperatures in your environment, right? What season you're composting in, the size of your particles, the bulk density, the porosity of your materials, how much moisture is there, which compost method you're using, and what available equipment you have. So small piles will maintain higher internal oxygen concentrations, but large piles will retain heat better than small piles. And just in case you're curious, bulk density is the ratio of the total weight of the compost to its volume, right? So how heavy it is based on how big it is. So compost pile sizing guidelines. This is in one of those publications that I shared with you from Dr. Chen and Mario. And this is just giving you kind of an indication of some size ranges in feet for static piles, you know, a windrow compost or an aerated static pile. So you can see your aerated static piles can actually be a lot bigger because you're pre-mixing all those materials before you set it, and not forget it, but you set it and then come back to it and make sure the oxygen's coming through. Your static piles can be a little bit shorter and a little bit smaller. But even so, you can see that you're going to need some room to do this correctly. And then moisture, optimal composting is going to happen when your moisture content is between 40 and 60% by weight. So when you reduce that, when you get low moisture level and your compost starts to dry out, those microbes are going to stop working. So that limits their activity. And if you've got too much moisture, then you start to have anaerobic bacteria move in, or the bacteria that don't require oxygen to work. And that's when compost gets stinky. So if you've ever said, oh, I don't want to compost, it always is smelly, or I hate it because it's like that, that's not healthy compost. That's anaerobic compost. Compost, even when it's full of really foul stuff, should actually smell just fine. So when you're turning your piles, you're going to want to monitor and add water as needed to maintain that moisture content. And then if you're using static piles, it's actually good to start out by making it a little bit on the wet side. So maybe between 65 to 70% moisture when you begin, because you're not going to be watering it or turning it to, you know, give that introduction of more water. And then some composters, especially large scale commercial composters who are using those static aerated systems, actually can blow humidified air through those pipes into the pile. So you can believe that they're probably using a lot of pretty high-tech sensors and other tools that let them know exactly where they are in that percentage. You know, this really is, what's so cool about compost is that it's definitely an art and a science to do it right. So I mentioned that I was going to talk about curing really quick. So curing is the period of time that happens after the thermophilic active phase, right? This is when your composting subsides and gradually your temperatures come down to around 100 degrees Fahrenheit. And then again, those mesophilic microorganisms come back in and recolonize, and compost starts to cure. So your organic materials are continuing to decompose and convert to biological stable humic substances after that high heat period. And this is also a time when other potentially toxic organic acids and other resistant compounds stabilize. So there is no clearly defined time for curing. Common practices in commercial composting could be anywhere from 1 to 4 months to even as long as 6 to 12 months. And so how do you know that your compost has cured? Well, if your compost is completely finished, it's no longer going to heat up, even if you mix it and add a little bit of water. It's going to maintain that sort of static, you know, low temperature. The initial ingredients that you put together are no longer recognizable. You know, if you pick up a handful, you're like, I don't see straw and poop. I just see brown, crumbly substance. And typically it's going to smell good at this time, right? It just smells like earthy, ozone-rich organic soil. So that's kind of how you might tell. But really, it's no longer going to heat up, and that's going to give you a really good indication. So give it some time. And here's just a little graph On time, we're going to enter the active phase. We're going to remain at that active thermophilic phase for a period of time to reduce the pathogens and weed seeds. And then we're going to cool down, and then it's going to maintain at the curing phase for a period of time until it's completely broken down and ready to use, at which point it is called mature. So if you're composting on farm, it is a requirement of the rule that you document your process and you keep records of how many times you turn it and what your temperatures are, so that you're documenting that in a turned pile, you're reaching 131 days for 15 days. And if you're using a static aerated pile, you're reaching 131 degrees for 3 consecutive days. So this is your best way to keep track of this. And this is a template that's available. It's been given to you also today. And then it's also available on the Produce Safety Alliance website. And if you've attended any of our trainings, it'll be on the little USB drive that you got. And so this is just a great way for you to keep track, right? If you're making compost yourself on your farm. Now, what about if you are purchasing compost from a supplier, right? This is something we get a lot. I don't have time or equipment to make compost, so I order my compost. Well, if you are purchasing a compost that you want to use as treated from a third-party supplier, then you have to document that that soil amendment had been treated, handled, and stored in a safe manner, just like you would document it if you were making it yourself. So the requirements include documentation that the treatment used to make that compost is scientifically valid and was carried out with the appropriate process monitoring, right, of turnings and temperature, and that the amendment has been handled, conveyed, and stored in a way to risk cross-contamination by another untreated soil amendment. Now, this is the tricky part. There is a template here available to you, and I believe that I sent this as part of your documentation. And if not, this is also downloadable from the Produce Safety Alliance website. This is a sample letter to send to your produce supplier to ask them to fill out and return to you. You can personalize it, and it tells them exactly what it is that they need to document for you to meet that requirement. All right, so you can give this to them and you can walk them through it or talk about it with them. Now, the challenge is that the produce safety rule requires that this documentation be updated at least annually if you're using biological soil amendments of animal origin that you purchase and you're using them as a treated product. And then the FDA states in the codified regulation that a certificate of conformance would meet the above record keeping requirements. So that letter in the previous slide, if you can get them to fill that out and give it back to you, keep that as your record, and that will satisfy your record keeping. Now, if you cannot obtain this documentation from your supplier, probably the most practical solution is just to handle and apply the soil amendment as if it were untreated, right? And we'll revisit what that meant again. So again, it means that you've got to handle it in a certain way. So in preparation for today's talk, I did reach out to a number of compost suppliers that I could find. Some of them, their phone numbers were no longer right. Some of them didn't answer the phone or respond to the email. I did end up talking to 2. I talked to Winds Compost in Haley, or in the Sun Valley area, and I talked to Cowgirl Compost, which is located here in the Treasure Valley. And both of them did respond to me, really eager, to try to help. But I still don't know that we are really quite there yet with our compost providers in Idaho. And this is a piece of work I think that maybe we need to work on to help the industry understand how to help you as the grower. I think the demand for this documentation has been really low in general. And so they're just not sure. I think most of them probably are composting in an approved method. They're just not documenting it. So Cowgirl Compost sends a letter of product guarantee, and they do have laboratory testing, but I don't know if the laboratory is testing for the pathogens or if they are simply getting an analysis done like you would for a soil test. So this is something further to explore. They did say that their test results are available on request. So I would ask them, because it does talk about their process of monitoring moisture, turning their rows, recording temperatures. So I'm really hopeful that their documentation would help you meet that requirement. And the Winds Compost that I talked to, he said that they are in the process of moving into a new division where they're going to actually be handling biosolids or human waste. And as a result, they're going to be having this process documentation for all the compost that they make, whether it's landscape or manure based or human waste based. And those two are not going to come together, by the way. I just wanted to point that out. All right. Another thing that I found is there is a seal of assurance, testing assurance through the U.S. Composting Council. Now, I'd want to actually spend some time with maybe someone from FDA or with our regulator to double check on this. But from what I could tell, the microbial count in a certified compost product would very closely, if not exactly, match the FSMA requirements. So I want to look into this a little bit more. Right now on their website, they did not list any Idaho growers, but if you're a small farm and you're purchasing compost, maybe even in bags, and it's coming from like Washington or Oregon or somewhere else, you might look for this seal. And this, again, is something I want to continue to explore with our regulators and with FDA to figure out how we can find that middle ground with our producers of compost and our users of compost. And so again, if you're in doubt, if you can't get the documentation, if you did not keep documentation of compost that you're making, again, consider it all untreated and wait 120 days between applying those products and harvesting the crop if it comes in contact with the soil, and 90 days if it grows above the soil or does not come in contact with the soil. Right, so this is always your default, is to go back to using it as an untreated amendment. And just a review of the record keeping, right? This is directly from the rule for any biological soil amendment that you use. And again, if you're not using them, you don't keep the records, right? You must establish and keep records for the products that you receive from a third party, right? Including their process used to treat the soil amendment. And that they've handled it and conveyed it in a manner that reduces the risk of contamination. And then if you are making or you're treating a biological soil amendment on your own farm, right, that you keep that documentation of the process controls, the time, temperature, and turnings. And then again, it's a good idea to keep records of how and when you use and apply these products, just in case comes up in your inspection. So we know that compost has so many benefits, and manures too, in agriculture, in feeding soil microbes, in increasing our soil tilth and improving our soil texture and water holding capacity, and just being really good in general for plants. And it's also a great way to use up materials that would be considered a waste product, but that are actually a very valuable resource. So I hope that this has helped you to understand a little bit better how to use these products safely on your farm, maybe how to begin the journey of composting if that's something that you think you want to do on your farm. And I would love to entertain any questions in our last 3 minutes. Gosh, I'm sorry, I had a lot to talk about with composting today.
So at this point in the chat, we haven't had any active questions. Really, we had one that was requesting studies for scientific validation that they could review, which I said that we'd make available in our follow-up email. And then I also had a question about the letter for distributors, and I said I'd also make that available. I just wanted to note that Zoom doesn't really allow us to attach all of the resources we want to attach, which is unfortunate, but I'll make sure that everybody has everything she's talked about either today or tomorrow, as well as the recording. And if you have any questions on it, once you have your hands on them, just let us know and we'll definitely follow up with you.
Yeah, and I should mention too, if there's another process that you want to use, like maybe an anaerobic digester, or maybe you're really doing worm composting on a large scale, we can connect you with some scientists or reader safety network that might be able to help you figure out a way to validate that process, so that your material can meet those microbial standards. So it's just those two types that are actually codified in the rule, but that doesn't mean those are the only two ways that you can deal with waste products or biological soil amendments on your farm. They're just the two most commonly used and two that have a lot of data behind them showing that when done in that manner, the microbial count comes down to that accepted level. Oh, it looks like a really cool comment from Billy Mitchell. Yeah, I'll look at that. Thank you.
We just got one question from Norman. What pathogens are associated with fish emulsions?
Oh, right. Gosh. You know, not offhand, I'm not sure which ones. There might be some listeria involved. I would want to research that before I got back to you. I think a lot of the fish emulsion products that you can buy over the counter have been heat treated or chemically treated in a way to be safe to use. But we would probably have to get back to you on that one in terms of what are the primary, you know, microorganisms of concern, and how we would want to handle that product, especially if it was, you know, you had access to maybe the raw materials of fish emulsion. That's a really good question. We make sure and jot that one down, Lou.
Well, it looks like Casey might have an answer for that.
Okay.
No, I would agree with Ariel. I think that listeria would be the first one to come to mind, but then I think from there, we just require some additional research to understand what other risks would be associated with that.
Oh, and we had a really good comment from, we've got a pro on the call. I really appreciate somebody who has been a part of the U.S. Composting Council, saying that that certified compost seal of approval does not exactly meet the FSMA requirement, but they're hoping to help find that middle ground. And then also that yes, the demand has been a little bit lower, especially in states where our produce, you know, growers are a smaller number. But thank you for giving me that comment. And I would definitely like to reach out and talk to you more about that so that I've got the best information possible for our growers. Ah, and my goodness, David Ingram was on the session. I liberally stole his graphs and things, and I'm so glad now that I documented them. That's wonderful. Thank you so much for attending.
And I just got another question regarding contact information. I'll make sure that everyone is CC'd on this email that I send out to update everybody on the stuff that, all the resources we send out. So you'll have everyone's contact information that was on the call today. So no worries.
Yeah, and definitely. And when you get those publications from Lou, Dr. Chen and Mario's contact information is also on those publications. They're also on our website. And so for like really technical compost questions on a large scale, they are the guys to go to. They can help you design your system, troubleshoot it, come up with those recipe mixes. Really, that's what they specialize in. And I just can't praise their work enough.
Okay, so it looks like we're a little bit over time, so we're going to go ahead and for today. Just one more slide left on here just to talk about some of the past webinars that we've had and just kind of loop back around. I know we're a little bit over time, so if you want to jump off or need to jump off, that's totally fine. Thanks for being here. But I just want to take 1 second to just say that these are the 6 webinars that we've done over the last 2 years, essentially from last April to this April. Last year, we did a lot of focusing on inspection outcomes of the 2019 inspection season. And that's kind of what informed the webinars that we had that year, which are all available on our website at the link below. I'll make sure to also send this information out so you don't have to type that in right now because it's just on your screen. But basically, last year, we focused a lot on hygiene, sanitation, record keeping, because those were the things that came out the most of our inspections and as things that we are seeing the most areas of non-compliance in. And then this year was more based on survey data, based on things that growers are still having an issue with or things that are more difficult to understand than others. And those were mostly composting was a big one, pest control within fully enclosed buildings, and also trying to understand how the programs of the Good Agricultural Practices GAP program and the FSMA Produce Safety Rule programs fit together to make a holistic idea in Idaho of what produce safety means from the governmental perspective. So we have all of that available, and as well as some really great other resources, and I'll make sure to make all of those available either today or tomorrow, depending on how quickly the video uploads, but I'll make sure that we have all of that available for you guys. And all of these are already on our website, except for today's. So thank you so much for being here. And thank you, Ariel and Casey, for both helping out today and the great presentation that we had. So go ahead.
Thank you all.
Thank you.
Thanks, everyone.